and welcome to the wolfSSL live webinar, Quantum Leap in Avionics, Enhancing Security, Airworthiness, and Safety. Presented by wolfSSL Senior Software Engineer Eric Blankenhorn and Cisco Technical Product Marketing Manager Amani Kochal. My name is Shizuka and I'll be moderating the webinar. All attending will be in listen-only mode. If you have a question, please use the Q&A box. We will host a Q&A session following the presentation. The webinar will also be recorded and made available on our YouTube channel shortly after the presentation. If you'd like to stay updated with all the latest from both SSL and Cisco, follow us on X, connect with us on LinkedIn, and subscribe to our YouTube channel. Also, feel free to email us at fax@wolfssl.com if you have any additional questions. Before we get started, I would like to introduce our presenters. First, we have Eric Blankenhorn, a senior software engineer at wolfSSL. With over 25 years of experience, Eric specializes in developing embedded solutions. Joining him is Amani, the technical product marketing manager at Cisco. Amani brings extensive expertise in data science, industrial engineering, and edge technologies. Now let's take a quick look at today's agenda. We'll begin with the introduction to wolfSSL, including a technology overview and a discussion of wolfSSL's key competitive differentiators. Afterwards, we'll move on to the company introduction from Cisco, where they will share insight into their product and certifications. Finally, we'll cover the integration of both technology before opening the floor for the live Q&A session. And now I would like to turn it over to Eric and Amani to talk about quantum leap in avionics, enhancing security, airworthiness, and safety.
wolfSSL is a leading provider of cybersecurity solutions, specializing in lightweight embedded security protocols and products. Founded in 2004, wolfSSL has emerged as a trusted name in the industry, catering to a wide range of clients spanning from individual developers to large enterprises and government agencies. One of the key differentiators of wolfSSL is its commitment to open source principles. The company actively contributes to open source projects and maintains a transparent development process, allowing for community collaboration and peer review. This not only fosters innovation, but also instills trust in the security of wolfSSL's products among developers and users alike. Working closely with a broad variety of RTOS, tools, and hardware vendors allows wolfSSL to take advantage of the latest technological innovations. In addition to its security projects, wolfSSL provides professional services, including security audits, consulting, and training, empowering organizations to enhance their cybersecurity posture and mitigate risks effectively. This approach underscores wolfSSL's commitment to delivering value beyond just software solutions, striving to establish long-term partnerships built on trust and mutual success. Moreover, wolfSSL prioritizes customer satisfaction and support, offering personalized assistance and timely updates to address evolving security threats and industry standards. The company's dedicated team of security experts works closely with customers to understand their unique requirements and provide tailored solutions that align with their specific use cases. wolfSSL is committed to providing secure and reliable cryptographic solutions, and to demonstrate this commitment, the company actively pursues various security certifications for its projects. These certifications serve as independent validations of the security and quality of wolfSSL software, providing reassurance to customers and stakeholders about the trustworthiness of their implementations. This slide is a good overview of our current product lineup. You'll see here our wolfSSL library, which is our core product, in combination with wolfcrypt, for either just crypto only or the full TLS stack. With wolfcrypt, we have a couple of certified versions available, including FIPS 140-3, which, by the way, just completed the validation process. We have a DO-178C certification for Avionics and also an asynchronous crypto module. We have an MQTT implementation called Wolf MQTT. for the client side, and an SSH client and server library called wolfSSH. TPM 2.0 library called wolfTPM, our secure bootloader called wolfboot, wolfSentry, which is an embedded IDPS solution, wolfentropy for random number generation, and our newest project, wolfHSM. We offer commercial support packages and consulting for the curl project as well. We also provide a version of curl that's been pared down for resource-constrained devices called tinycurl. In the bottom left here is a set of language wrappers for wolfSSL. The library is written in the C language, but we do have users that want to use this from Java either through the JSSE or JCE provider or just straight JNI. We also have users who want to use this in C#, Python, and JavaScript. At its core, wolfSSL is renowned for its flagship product, the wolfSSL Embedded SSL TLS library, which is designed to offer robust cryptographic functionality while maintaining a small footprint, making it ideal for resource-constrained environments such as IoT devices, embedded systems, and mobile applications. This library is optimized for performance and efficiency, ensuring secure communication protocols without compromising on speed or memory usage. Here are some other important features to point out. We have our certified and validated versions of wolfcrypt. We have ported a number of different web servers to use wolfSSL. For the server side, Apache, Nginx, Lite, and also Mongoose. We have hardware crypto support for a bunch of different platforms now and can easily expand that if needed. So in the beginning, we talked a little bit about the engine and provider solutions. This is really a quick way for an application that's currently using the OpenSSL API, which may have a FIPS certified cryptography that's going to go out of scope or into the historical list pretty soon, to switch over to wolfSSL and wolfcrypt certified FIPS solutions. It's super easy to swap out just by linking in the new wolfcrypt FIPS code. Then you can continue to use those OpenSSL APIs on the top, and all the cryptography underneath is going to be using wolfcrypt FIPS. Alternatively, you could use the compatibility layer, which would keep the OpenSSL API in your application, but remap them to wolfSSL APIs. The advantage here is that it allows you to bypass most OpenSSL specific vulnerabilities, as well as using the best tested TLS stack and cryptography. wolfSSL has also been following the NIST recommendations for post-quantum cryptography. We have implemented the finalists from the standardization practice: dilithium, Falcon, and Kyberchem. Unfortunately, we do not actually know that these algorithms will resist attacks from quantum computers. In fact, we are not 100% sure that these algorithms are safe against a conventional computer. So for now, we can hedge our bets by hybridizing post-quantum chems with the conventional algorithms that we trust today. We have not only integrated post-quantum chems, but also hybridized them with ECDSA over NIST-approved curves. wolfSSH, as the name suggests, it provides a lightweight embedded secure shell library for remote access and data exchange. It's built on the same principles of efficiency and performance as wolfSSL. wolfSSH offers robust encryption and authentication mechanisms, allowing developers to implement secure, encrypted communication channels in their embedded devices and applications. wolfboot is an open-source, secure bootloader designed to protect the boot process of embedded systems from tampering and unauthorized access. By establishing a chain of trust from the initial boot stage, wolfboot ensures the integrity and authenticity of firmware and software components, safeguarding against malicious attacks and unauthorized modifications. MQTT is a lightweight messaging protocol commonly used in Internet of Things applications for efficient communication between devices and servers. wolfMQTT provides an embedded MQTT client library with support for secure connections via TLS, enabling developers to implement secure and reliable messaging solutions in resource-constrained environments. wolfSentry is a universal dynamic embedded IDPS, or intrusion detection and prevention system. At its core, it features an embeddable firewall engine, both static and fully dynamic, with optimally efficient lookups. Wolf Sentry is dynamically configurable and can arbitrarily associate user-defined events with user-defined actions, contextualized by connection attributes, tracking the evolution of the network transaction profile. TPM, or Trusted Platform Module, is a hardware-based security module used to securely store cryptographic keys, perform cryptographic operations, and attest to the integrity of system components. Wolf TPM offers a software-based TPM implementation, allowing developers to leverage TPM functionality on systems that lack dedicated TPM hardware. This enables the adoption of trusted computing principles and enhances the overall security posture of embedded devices and applications. Wolf HSM provides a portable and open source abstraction to hardware cryptography, non-volatile memory, and isolated secure processing that maximizes security and performance for ECUs. Automotive HSMs, or hardware security modules, dramatically improve the security of cryptographic keys and cryptographic processing by isolating signature verification and cryptographic execution, which are the core of security, into physically independent processors. Next up, let's talk more in depth about some of the notable security certifications offered by wolfSSL. The Federal Information Processing Standard, or FIPS, publication 140-3 is a U.S. government standard that defines security requirements for cryptographic modules. wolfSSL offers a FIPS 140-3 validated cryptographic module, demonstrating compliance with rigorous security standards mandated by government agencies and regulated industry such as finance, healthcare, and defense. This diagram shows where the Wolf Crypt FIPS module fits in relation to wolfSSL in the application. We've drawn our FIPS boundary around a subset of wolfCrypt itself, which means the TLS code is out of validation scope. This was done by design, since most of the vulnerabilities and bugs that we find are fixed in the TLS layer, not necessarily down in the crypto level. So a FIPS customer can use the same FIPS validated library from release to release of wolfSSL, still updating the TLS part of that library without invalidating their certified application. We have one active certificate for wolfCrypt FIPS on 140-3. That's certificate 4718. We have a couple more for FIPS certifications pending that will allow us to help other customers down the road. For new validations, there are a couple of solutions. We can add a new operating environment for our existing certificate. An operating environment, or OE, is a combination of the operating system, the processor, the platform, and the wolfCrypt version. We could also do a rebranding validation where we would rebrand our certificate in a customer's name, and then if needed, we can either grow or shrink the module boundary. That can sometimes be a little bit more of an involved process, but might be needed depending on specific FIPS requirements and of course the time frame. All of this is dependent on the scope of the project, the platform, if it's a standard or non-standard platform, and what we're seeing as far as timeframes for the lab and the CMVP. DO-178C is a safety-critical software development standard widely used in the aviation industry. wolfSSL offers a DO-178C compliant version of its embedded SSL TLS library, enabling developers to integrate secure communications capabilities into avionics systems and other safety-critical applications while meeting regulatory requirements. The primary goal of this product is to provide the proper cryptographic underpinnings for secure boot and secure firmware update in commercial and military avionics. wolfSSL brings trusted military-grade security to connected commercial and military aircraft. Avionics developers now have a flexible, compact, economical, high-performance, common off-the-shelf solution for quickly delivering the enhanced secure communications that can be readily certified to DO-178. The design assurance level specifies the criticality of the requirements. wolfSSL is taking components of wolfCrypt through certification to the highest level, DAL-A. This is a list of the components of WolfCrypt that wolfSSL has certified to DO-178. We are constantly adding to this list, and we are currently working on certifying other products, including WolfBoot, WolfTPM, and the DTLS stack in wolfSSL. By obtaining these certifications and adhering to industry best practices, wolfSSL demonstrates its unwavering commitment to delivering secure and trustworthy cryptographic solutions to its customers. These certifications not only validate the quality and reliability of wolfSSL's products, but also enable customers to meet regulatory requirements and mitigate security risks effectively in their applications and deployments. And with that, I'd like to turn the presentation over to Amani to introduce the solutions available from SYSGO.
So hello everyone. So let's start first by presenting SYSGO as a business. So SYSGO is founded in 1991 and it began as a service-oriented company in the embedded market. Today, we stand as the leading European operating system vendor for embedded systems. Our portfolio includes board support packages, certification kits, and a broad array of professional services such as product training and consulting. In 2012, SYSGO became a member of the Thales Group while retaining our own brand and operational autonomy. And we do have a strong international footprint with key operations in Germany, France, the Czech Republic, and the UK. Moving forward, let's explore our strong network of hardware partners. These collaborations enhance our product capabilities and ensure cutting-edge solutions for our clients. And it's worth mentioning that we hold gold partnerships with several key companies, which are highlighted in red in this slide. And each of these partnerships brings unique technological strengths to our offering. Alongside our hardware collaborations, we also have a robust ecosystem of software partners, of course. These alliances strengthen our service offerings and support our commitment to innovation and security. In SYSGO, we do have a number of products that have been designed to meet the highest requirements when it comes to safety and security, including PikeOS, first released in 2003, which is a hypervisor and a hard real-time operating system based on a separation kernel. AlienOS, our first product, an industrial Linux distribution with a long-term support. And more recently, PikeOS for MPU that is compatible with lightweight systems that comes with a memory protection MPU only, which provide real-time partitioning for MPU architecture. We also provide seamless customer product development and management, including system architecture and security approach, hardware integration, long-term customer support, tools and services to cover the full product lifecycle. And in SYSGO, we drive innovation and create value for customers globally in different segments, like aerospace, defense, automotive, railway and transportation, industrial IoT, and medical and healthcare domains. We do have expertise allowing us to understand complex market dynamics and anticipate trends that impact our customers' businesses. Let's move now to introduce PikeOS, SYSGO's flagship product, known for its robust architecture designed specifically for safety-critical systems. PikeOS is not just a software, it is a cornerstone for security and functionality in embedded systems. So what makes PikeOS unique? So PikeOS operates as a Type 1 hypervisor and separation kernel. This means PikeOS is installed directly on the hardware, forming a primary layer of security and safety. Above this layer, users can integrate various technologies, leveraging PikeOS to manage and secure their operations. So how does it enhance safety and security? Well, PikeOS employs a concept known as MELS, or multiple and dependent levels of safety and security. This framework allows the coexistence of secure and non-secure applications on the same platform. With PikeOS, we manage both when and what, controlling the timing and access of operations on hardware, ensuring that tasks are performed securely and efficiently. This innovative approach allows PikeWest to address complex challenges in safety-critical environments, making it a pivotal solution for our clients. Moving to the next slide, it's worth noting that PikeWest uses a modular approach, allowing for seamless integration of diverse software components. This empowers the creation of customized solutions that precisely match the specific requirements and configurations of various applications. As we can see in this slide, on the lower level of PikeWest, we find the PikeWest microkernel, which consists of a generic part, a CPU architecture-dependent part called ASP or Architecture Support Package, and a platform-dependent part called PSP or Platform Support Package. On top of that, and in the user mode level, we have the PikeWest System Software Component, which is the first user space application launched by the PikeWest microkernel. It is responsible for initializing partitioning, inter-partition communication, and health monitoring. On top of the core operating system, there we can find the different partitioners. Software partitioners here are also called virtual machines because it is possible to implement a complete guest operating system inside the partition, which executes independently from other partitioners. PikeWest supports multiple guest operating systems, including POSIX, ARINC653, Linux, Android, LNOS, PikeWest Native, Windows, and many more. PikeWest partitioners have the capability of effectively handling mixed criticality applications. By isolating software functions, it enables different applications from safety critical to non-critical to run securely on the same platform. This makes PikeWest a reliable choice for industries requiring a balance between safety requirements and versatile application integration. And this will allow industries to reduce the certification effort, to resolve licensing issues by means of separation, and also the reusage of legacy code. And in this context, we are ensuring the support of mixed criticality applications by using two main security mechanisms, which are resource partitioning and time partitioning. So in resource partitioning, we are ensuring that every partition in PikeWest has its own dedicated set of resources. By doing this, we are enforcing strict isolation between partitioners, preventing one partition from accessing the resources allocated to another. Here is the MMU role to enforce memory isolation that contributes to the overall resource partitioning strategy of PikeWest, preventing any unauthorized memory access between partitioners. Time partitioning also is one of the security mechanisms to support mixed criticality applications. PikeWest ensures time partitioning by employing a real-time scheduler within its microkernel architecture. Each partition is allocated a specific portion of CPU time and priority, which the scheduler enforces. And this guarantees that partitioners receive their allocated CPU time, preventing one partition from monopolizing resources. So our journey started in the year 2000 with a clear mission, which is to enhance the way products are certified across different industries. We set out to provide a higher level of assurance, which led us to an important realization that the principles of certification could be applied broadly with only minimal adjustments between domains or sectors. Initially, we focused on the avionics sector, known for its rigorous standards, often considered the gold standard of certification. So starting with Dell A in avionics, we improved our skills in understanding the nuances of certification across different markets. This expertise allowed us to navigate the subtle differences between sectors such as defense and aviation, which are surprisingly similar in most of their certification demands. As we progressed, our strategy evolved. So while we don't have unlimited resources to tackle every market simultaneously, we adopted a focused approach. Master one, understand the differences or the deltas, and then move to the next market or domain. And this method has proven to be efficient and effective. So for example, once we find a customer that wants to certify the software that we have built for an arm chip in rail, but they want to use it in automotive, we know how to do that in a more efficient way. So we can leverage our deep understanding of these deltas to facilitate certification more efficiently. So this approach not only saves time, but also ensures consistency and reliability across different applications. So in this slide, you can see already where we are today. So we are covering everything from general standards that apply worldwide to very specific ones, like those needed for energy sector, for instance. So it's all about being adaptable and deeply understand the rules that different industries are following. So what does this mean about security? Well, what we discovered along the way is that if you can separate things in time and space from safety perspective, actually that's what you need to do for security also. So if you can prove that things will not happen, or you can control when things happen, then that's actually a good thing for security also. And actually, we went off and looked at the security market as well as safety and said, okay, how do we apply our knowledge from a safety perspective to the security market? As we explored the world of certifications, we found out that different industries have their own special rules for safety. These safety rules have been around for a long time and they don't change much. In the world of security, however, things are a bit different. There are many new rules popping up and they are still figuring out how to work best. To handle this, we decided to focus on one main standard called Common Criteria, which is a big deal in cybersecurity. Common Criteria is a globally recognized standard in cybersecurity, and we pursued this path and achieved independent certification at EAL5+, which is the highest possible level for software considered out of context. This certification strictly evaluates the software itself, independent from any system integration. And actually, it took us a while to get our official certificate. And as a German engineering company, we uphold a strict policy, which is no certificate, no claim. So unless we have actually got the certificate on our hands, we don't say we've done it. It's a discipline that defines our commitment in providing robust security solutions. Additionally, we offer a versatile platform that can be used without immediate certification requirements. That gives our customers the flexibility to develop with an eye towards future safety and security changes. This capability is especially valuable in sectors like oil and gas, where regulations are anticipated but not yet defined. Our proactive approach ensures that whatever the future holds, our partners can trust us to navigate it together, building secure, reliable solutions for different industries like transportation, aerospace, and automotive. So the type of security requirement that we have certified with PikeOS is in order to give you a partition operating system that will help you to create a secure architecture for your actual device. So strict separation in the spatial and time domain is one of the most important components of the operating system, and it's one of the security functionalities that is being evaluated. But there are also, of course, functions around access control of resources, guarantee the availability of resources. So I mean classic requirements that will be around confidentiality, availability of your assets. So we also make sure that there is no residual information that is being left when partitions communicate between each others. So this gives you an execution platform that will help you to define a software architecture that is resilient to threats and to attacks. And of course, you may add additional security functionality, like for example, cryptography, that are not necessarily handled by PikeOS by default or not included in the scope of the evaluation. But our goal is to give you a secure foundation for robust software architecture on which you can base your design. So as you can see in this slide, we didn't include all of the security functional classes in the way we have described it, but we have focused on instance on the protection of user data, identification of requirements, and security management and resource utilization. So when you define a security target with common criteria, you are not forced to pick requirements from every class. You just adapt it to your particular device. So in the case of EAL5+, normally we should have stopped in the column that is titled EAL5. But because we also want to address some specific French markets where there is a requirement for the NC, so the equivalent of the BSI for Germany that relies also on common criteria, and this requires evaluation that goes beyond EAL5. That's why you see that for certain security assurance classes, we went beyond EAL5, and in particular for the vulnerability analysis. And this is important because that means we basically spent quite a lot of time making in-depth analysis of what are the threats of the vulnerabilities in the hardware and in the software to address this. So we talked about common criteria so far, which is a generic cybersecurity standard. But of course, once we address solutions for avionics or automotive, our customers are asking for compliance to industry-specific requirements. So what we did is that with the experience we gained using common criteria as a foundation for our cybersecurity demonstration, we did some compliance analysis to establish some compliance metrics between these standards. And what we found out in this particular case for the different domain like avionics, automotive, industrial, that most of the security assurance requirements map directly to common criteria requirements, but for bulk of them. And there are just few that are only partially compliant that would require some additional activity if we need to be compliant to either avionics, automotive, or industrial specific requirements. There is also a set of requirements that are not applicable for the operating system, simply because these are requirements that are addressed at the system level, so not really by the operating system, but by the end customer. But of course, we are there to support this, but this doesn't really apply in the context of a component of a system, and this component being the operating system. So when it comes to certification, we support all major safety standards, and SYSGO has a very long history in certification projects, and almost every engineer of our team has been involved in such certification project, whether it's safety or security related. In this slide, you can see the PikeOS components and their certification state. So you can see that the microkernel is fully certifiable, which means you can provide all necessary documentation, including traceability and coverage. However, if you have your custom board, the PSP needs to be developed together with you as customer. When it comes to operating systems and certifiable APIs, we have a certifiable POSIX, and of course the PikeOS native is pre-certified. And in addition to that, for PikeOS, we also provide a certifiable file system and a certifiable UDP stack. Another important topic when it comes to certification is the tool qualification. So basically, you can do the certification without any tools being qualified, as long as you verify your results. And if you do that on a binary basis, it is basically possible, but very, very tedious. Therefore, SYSGO has qualified the major tools, for example, the ROM image builder and the VMIT builder. And here, the VMIT stands for the Virtual Machine Initialization Table, that it is responsible for the configuration of the virtual machines. So both of those tools read a configuration file in XML and convert it to a binary. And since those tools are qualified, you can easily do the validation on source code level, which means you can quickly incorporate changes without doing the complete revalidation on binary level. So moving to the next slide, and here we are highlighting the diverse avionic applications that can run on SYSGO's PikeOS. So we can take as example the flight management application, the cockpit display application, the engine control units, and the stability augmentation application. Each of these applications benefit from PikeOS's ability to provide strong separation and security between processes, ensuring that critical applications can operate without interference. So as we move forward in our presentation, let's explore our integration solutions with wolfSSL and SYSGO, which are essential for reinforcing the security infrastructure of our systems. WolfCrypt, a FIPS-certified cryptographic engine, is crucial in securing data across our embedded devices with a variety of encryption algorithms like AES and RSA, to mention a few. Alongside, we use SYSGO's PikeOS, a certified operating system and hypervisor, crucial for systems requiring high certifications under standards like ARINC-C and POSIX. And here we have implemented the wolfboot for secure boot processes that guarantees the integrity and trustworthiness of system startups across multiple hardware platforms. This suite of integrations not only elevates our compliance with global security standards, but also streamlines the certification process, enhancing operational readiness and delivering reliable solutions to our clients. So today we have explored the powerful integration of wolfSSL's SSL TLS cryptography with SYSGO's PikeOS. This collaboration brings enhanced security compliance, crucial for industries that have high regulation requirements like avionics and automotive. This integration not only delivers FIPS-certified robust encryption, but also streamlines the development process that remarkably reduces the time to market. And this is actually a key advantage for any business looking to stay competitive in a fast-paced, technology-driven market. Additionally, the flexibility of PikeOS allows us to cater to diverse architectural needs, ensuring that our systems are both secure and adaptable across various operational environments. And this architectural versatility, of course, is crucial for maintaining security and functionality in mixed critical environments. So, combining these features with market-ready solutions, SYSGO and wolfSSL partnership provides an end-to-end security framework that is secure by design. It equips our customers with everything they need to deploy secure, reliable, and compliant systems quickly and effectively. So in conclusion, this integration not only supports current security needs, but also positions our customers for future advancements in security and technology standards.
Thank you, Eric and Amani. Let's move on to the Q&A. Please submit your question in the Q&A box. One attendee is raising hand, so Oliver, I will unmute you so you can ask question. Okay, so Oliver, if you have any questions, you can send it to the Q&A box as well. And there is a question. What are key security features unique to PikeOS that differentiate it from other real-time operating systems?
Thank you so much for the question. So this is a question directed to SYSGO, I guess. So the main key features that that makes PikeOS unique RTOS is that first, it is a type 1 hypervisor or separation kernel, which runs directly on the hardware. So this design is fundamental in providing strong isolation between different guest operating systems and applications running on the same physical hardware. Plus, we are implementing two main security mechanisms, as we mentioned in the presentation, like resource partitioning and time partitioning. And also, it's worth mentioning that the separation kernel of PikeOS is compliant with MELS architecture, which stands for multiple independent levels of security that ensures robust security by using strong and strict separation mechanisms, I would say. Also, we have a modular design for PikeOS, and this modular design allows for modular certification, as mentioned. And the last point is like we are compliant with common criteria, which is a big deal in cybersecurity, I would say. So, yeah, I hope this answers your question already.
Okay. There's a question for wolfSSL. Is wolfboot certified for DO-178?
Great question. Yeah, so basically wolfSSL has taken parts of the cryptography stack through certification for DO-178 C DAL8. We're always improving on that and adding to that boundary. And right now we are actually taking parts of the wolfboot stack through certification. So part of that certification is really like simplifying the code because it's extremely expensive for these types of certifications. So the less code that you have to actually push through for the reviewers to go through, the better it is for the customer and for us also. So that's kind of part of what the process of getting certification, it looks like, is actually going through and stripping out things that aren't going to actually be used by the end application. So that's in process, but not completed yet.
Okay, perfect. There's a question for SYSGO. What development tools and support does the SYSGO provide to help developers optimize their use of PikeOS for embedded applications?
Yeah, thank you for the question. So for the development tool, actually, SYSGO provides Codeo. Codeo is a SYSGO IDE, which is an Eclipse-based integrated development environment tailored for embedded systems. So this IDE actually supports the entire development lifecycle from simulation and emulation to software updates for deployed systems. Also, SYSGO provides documentation and user supports that will help the developer with every step that they need to go through PikeOS. So SYSGO offers details, documentation, training, consulting, and support services. So yeah, this is how we are supporting developers.
Mm-hmm. Yeah, perfect. There's a question for wolfSSL. What are the performance impacts of FIPS 140-3?
Oh, good question. Yeah, so basically what we've seen is that the actual cryptography parts are not going to be different, right? So the actual using of the cryptography is not any different. There is a little bit of an impact on startup. And one of the things so basically you have to run a test to ensure the validity of the FIPS module before it starts up and actually starts using that cryptography. And one of the things that was introduced by FIPS 140-3 standard was that you can do that on the fly. So in other words, you're in the FIPS 140-2, you basically at initialization time had to go through and test the entire module. With FIPS 140-3, you can offset that. And so you can not actually do the startup tests until the actual component gets used. So for instance, if your application does an AES encryption, early on, you'll see that AES test run right before that gets used. But if you're not using the RSA until later on, you can defer that RSA testing until later. So that's one of the performance impacts that we've seen from the FIPS 140-2 code or FIPS 140 code.
Okay, perfect. They have another question for SYSGO. Could you detail the safety and security certification that PikeOS has achieved for Avionics?
Yeah, thank you for the question. Actually, this is very important question. So the question is for the safety and security certification that PayQuest has achieved for Avionics. So I would start by safety first. So PayQuest has achieved the DO 178C certification standard, and we reached the highest safety level, the highest level of this standard, which is DAL A. For the security certification, PyQuest has been certified to meet EAL 5 plus of the common criteria, as I mentioned in the presentation. And it's also worth mentioning that PyQuest also complies with specific security requirements set by Airbus, which is Airbus SAR. So yeah, I hope this answers your question already.
Thank you. It was the last question. Thank you, Eric and Amani, for hosting an informative webinar, and everybody for joining today. And please don't forget to follow us on X at wolfSSL and at SYSGO, as well as our LinkedIn and YouTube channel. If you have any further questions, please email us at fax@wolfssl.com. Thank you again, and see you next week for securing medical and industrial connected products using Wolf TPM and SD33 KTPM. Thank you.